Alright, so today we're finishing up chapter 2, and we're finishing up with a little review of all the theorems that we've learned so far. You can think about it this way: it's a little of a reflection time for us, where we get to reflect and practice everything that we've learned so far. You see, in chapter 1 was all about the axioms. This was a crucial chapter where we learned everything that you can and can't do. It will serve you well for all the math classes that you take for the rest of your life. Amazingly super important chapter. It's amazing that people go through school for 12 years and not spend just 1 or 2 weeks just learning the rules, what you can and can't do. Well, we did that, and we try to do it extremely well so that you have no doubts what you can and can't do. That was chapter 1. Chapter 2, we learned how to deal with integers. These are things like -2 times -3, -2 plus -3. We learn how to do everything. -2 times +5. We learn how to add negatives. We learn how to multiply positives and negatives, how to multiply negatives and negatives. That's what's chapter 2. And we are right here at the end of chapter 2 right now. And this is a nice place because we're going to get to review all the things that we've learned so far. And we'll have problems, like one problem where you get to review almost everything that we've learned so far. That's why this is a nice place right here. It's a little reflection time where we get to reflect on all the things that we've learned and practice them. So talk is cheap. Let's do it. I should mention something here about adding things. We never add pieces of terms, right? Just like, consider this. What would you say if somebody said, you know what, I think I can add this, and I said, I'm going to add it like this. I'm going to try to add the 3 and the 4, and that would be 7, and then I have a 0 there. What do you think about that? That's 70. You think, well, that's kind of crazy, and let's think about that for a second. Why is that kind of crazy? The reason it's kind of crazy is because we don't just add 3 plus 4 and ignore, you know, whatever's on the other side of the 4. You can never ever do that. You can't just go adding, oh, I see a 3 and I see a plus and I see a 4. I'm just going to go ahead and add those. You can't add those while ignoring what's underneath, what's to the right of the 4. In other words, we don't add a piece of a number. We add entire numbers. In other words, we don't just add the first part of the number that we see. We try to look, we scan with our eyes everything until we see no more pieces of the number there. This whole thing comes together. It all goes or all stays. We don't add just little pieces of the number. We add the whole thing. That's going to be a super crucial idea for, you know, forever. We don't add pieces of terms. Same thing as numbers. We don't add pieces of numbers. Another thing we wouldn't do is here, consider this. Suppose I had 13 plus 47. You wouldn't just say, you know what, I'm just going to look at the, I'm just going to focus all my attention on the 3 and the 4, and I'd say that's equal to 1, 7, 7, because all I did was add the 3 and the 4 to give me 7. That's crazy. You don't add just pieces of numbers and ignore whatever's stuck to them. These things are stuck to them and they mean something. You can't just unstick it or chop it or, you know, cut it in half and say, you know what, I'm just going to ignore everything that's next to it. I don't care. Well, maybe you could if you're an outlaw. But the normal way of doing things is to scan the number until you see the end of it. Same thing with these ones. This would be a really bad idea. And I stress that because a lot of beginning algebra students have a tendency to do that with terms. So let me explain what I mean by that. So suppose you have this 3 plus 4 times 3. You have to think about the 4 times 3 as a term. This is one term. This is one term. Just like the other one where 40 was one number, this was one number. It wasn't two numbers, a 4 and a 0. It was one number, 40. Same thing here. This is one number. It's glued together by times. That's one term. So you can't just say add the 3 plus the 4 and ignore whatever's next to it. You have to deal with it somehow. So you could, for example, you could say, well, that's 3 plus 12. That's by times table. And of course, that's 15 by addition table. This would be an appropriate way to do it, addition table. Okay? And it's not the PEMDAS thing. The PEMDAS thing is full of crap. It's just it's the devil's work on earth. They invented PEMDAS because PEMDAS just stifles your creativity. It tells you do the parentheses, do the exponents, do this and this and that, and it's just not true. You don't have to do times first. Here, watch. Let me just prove to you why PEMDAS is so full of crap. It pretends that you have no creativity, no way of thinking. It wants to tell you what to do and how to do it and when to do it. And what's the fun in that? You know, it's treating you like an insect. Here, let me give you another idea. This is 3. This is 1 times 3 plus 4 times 3, right? I could say that by multiplicative identity. Multiplicative identity says 1 does nothing. So therefore, this would be the same as that. Now I can say, whoa, it looks like someone distributed a 3. So I have 1 plus 4 3s. That's how many 3s I have. I have 1 3 here, and I had 4 3s over here. That's by distributive law. So therefore, I really have just 5 3s. Whoa. By addition table, and so that means the same thing as 15 by times table. Okay, so there's another way to do it. And it's not necessarily shorter or faster, and I don't really care if it's shorter or faster. I only care that you understand steps perfectly, and that you understand that you're 3.5-pound brain human being who should be allowed to think like a human being. You're not an insect who should be told what to do, when to do, and how to do it. No, this is a different way of thinking. You get the rules. Here are the rules and the axioms, and then you're set free. It's like a musician. Here are the chords. Make whatever you want. Like an artist. Here are the paint brushes. You are the artist. Make whatever you want. That's a different way of thinking than PEMDAS. This is, I hate it, PEMDAS. Don't get me started on that. Anyways, but the one thing you have to keep in mind is we don't add pieces of terms. All right. All right. So what would you here? What could you do? Well, again, there's many ways of doing it, and all you have to do is just don't break the rules. And even then, maybe you could break the rules if you're a trailblazer. Here we could do distributive law. See, there's another problem with the PEMDAS. Do the parentheses first. Well, good luck. You can't do the parentheses first because you cannot add 2 plus x if you don't know what x is. So there goes your PEMDAS. 4 times 2 plus 4 times x. This is by distributive law. You could do that. Here I have 3 terms, so I don't add any one of the pieces of the term by itself. I think of them as 3 numbers separate. I could clean them up. I could take small, careful steps on each one. For example, I can know that 4 times 2 is 8 without a doubt by times table. And then I can associate these. This is plus, plus, plus. Whenever you have plus, 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 you can just focus your attention on any pair of them. That's called associative law of addition. And of course this would be 11 plus 4x by addition table. So beautiful. Not the fastest way, not the shortcut. That's not what we want. We want deep understanding of things. This is the Bentley of algebra classes. So who cares if you have to write 5 or 6 steps? They are beautiful steps and so perfect. This is like chocolate for your brain. This is like dark chocolate for your brain. So nice. It's like cheesecake for your brain. No. Cheesecake is bad for you. It's like dark chocolate. Alright, let's try a couple more examples. How about this one? On this one I try to scan how many terms I have. I see I have a plus here, so I'm focusing my attention on the number of terms here. I do that just so I'm careful not to add pieces of terms. These things are separate items, so I handle them separately. Let's handle this one. Between any minus and a number, I can always stick a 1 between there. Why? That's called the minus theorem. That's called the minus theorem. Remember that? Between any number and a minus, I can stick a 1. And now I still have 2 terms here. This is all times, 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 times. -1 times -3 times 2. This is all one item, one term. Plus, that's the those are the bookmarks, the separators. Then there's another term. So I handle each one of them separately, making careful steps on each one. For example, this one I know I can go with 35 by the times table. This one I have 3 items that are being multiplied. If you have 3 items that are being multiplied, you can choose to multiply either the first 2 or the last 2. Doesn't matter. That's called associative law of multiplication. So I'm going to choose to multiply the first 2, and that's the reason I can do that is because they're all times, times, times. I didn't cut through any pluses or minuses in that step, so that's called associative law of multiplication. It's beautiful. Then I need to do a multiply a negative times a negative. That would give me 3 times 2 plus 35. That's by negative times negative theorem. I told you we get to practice everything that we learned. Didn't I tell you? 3 times 2 is 6 plus 35. That's by times table. And of course this would be 41 by addition table. Yippee-ki-yay. So beautiful, so perfect. Not the fastest way, it's the best way. You know what the fastest way to do this is, actually? Actually it'd be like this. Put it on the Wolfram Alpha. Haha. Alright, should we try it again? Another tip that I have for you is you might want to change all your subtractions to additions, because then you have associativity, commutativity, everything. So I hate subtraction. So this becomes 3 plus negative 40. This is by definition of subtraction. And how do you add 3 and negative 40? Well, you got no business adding negative 40 if you don't have a good understanding of negative 40 is. Negative 40 is the killer of 40. How could I add it to 3? Well, I could separate this into little baby killers. I could have a negative 3 killer, and I'd be left with 37 killers. And of course that is by negative plus negative theorem. A little negative plus another little negative make a big negative. Negative plus negative theorem. This is plus, plus, plus. Now I have three items being added. I can move the parentheses, so it becomes 3 plus negative 3 plus negative 37. That's the associative law of addition. Of course this gets killed. They were born to be killers of each other. Those are additive inverses. And of course this just gives you negative 37 by additive identity. Perfect, so beautiful, step by step by step. A chance to reflect and think about all the axioms that we've learned one by one. It's beautiful, isn't it? How about this one? Again, I don't like the minus here, so I'm going to go with 3 plus negative 4 times 3. This is by definition of subtraction. And also I give myself some room to see my terms. I have 2 terms here. So I try to work with each term as much as I can. So that would be 3 plus negative 12. And of course this is by negative times positive theorem. And of course that means 3 plus negative 3 plus negative 9 by negative plus negative theorem. And of course that means 3 plus negative 3 plus negative 9 by associative law of addition. And of course that means 0 by additive inverses. And of course that means negative 9 by additive identity. By the way, I should warn you that this chapter 2 and chapter 1 were really special, because we got to break things down so nicely. In the future we'll have to focus on other ideas, and when we do that we might have to wrap all these things into just one thing called by inspection. By inspection means that we've already done all those steps like hundreds and hundreds of times, and we're comfortable with them, and so we're moving on to focus on other attentions. So maybe later you could go from here to here by inspection once you're comfortable with it. Okay, maybe by next chapter I think we're going to start doing by inspection. But right now we have to cherish this time when we don't do it by inspection. We show every single step. So perfect, so flawless. This stuff will make you the life of the party. I bet you if I take a screenshot of this and put it on my Instagram, I would get like 100 likes in 2 seconds. Boom. That's right. Alright, again here you would never ever consider breaking up those numbers. You would never consider just chopping up those numbers in here and focusing on that and say that's 273. That would be a totally bad idea. Again, I'm trying to emphasize, you look for terms. This is one term and this is one term. You don't add pieces of terms. Those two, the 3 and the 4 are just little pieces of the terms. You can't be oblivious to whatever stuck to them. You cannot be oblivious to whatever stuck to them. You can't just ignore whatever stuck to them. Same thing with terms. Check this one out. Again, you focus your attention. How many terms do you have? I've got 2 terms, so I'll go with this, 6 plus 12 by times table, and of course that would be 18 by addition table. That would be a good way to do it. It's not the only way to do it. I'm telling you, the PEMDAS thing is evil. It's not true that you have to do multiplication first. Here's an alternative way to do this. Let's go back in time here. Here would be an alternative way to do this. You say, well, it looks like someone distributed a 3, so that looks like 2 plus 4 3s. That's the distributive law. And so that's the same thing as 6 times 3 by the addition table, and so that's clearly 18 by times table. That would be another way. See, this idea, the way we're doing it in this class, where you have axioms and theorems, It gives you choices. It treats you like a human being. It says, hey, here are the choices. You do whatever you want with them. You're the artist. You're the chef. It's way, way different mentality than the PEM does. It treats you like an insect. Do this, this, and that. Tells you what to do, when to do, and how to do it. It's like, what's the point of being there in the first place then? If they want to do it that way, why don't they do it themselves? There's no human needed there. All right. All right, how about this one? We change all the subtractions to addition. I usually like to do that. So I have 3 plus negative 4 times 2 plus negative x. And so I think about this as having two terms. Alright, so I keep these things separate. You see the plus here separates. It's my bookmark where it separates the things. This is not a plus, this is a times, so these two things are glued together. Fortunately, we do have something called distributive law that can distribute that negative 4 times negative x. And now I have 3 terms. Look at that. I know because they're separated by pluses. And I got rid of all my subtractions at the beginning so that I just have pluses. I love pluses because we have commutative law of addition, associative law of addition, everything that's about addition, nothing about subtraction. So I have 3 items here. Sorry, let me see. So this was the definition of subtraction. Here I distributed. This was distributive law. I distributed this. And now we're here. Maybe I proceed cautiously. This piece I can clean up. That's negative 8. This piece I can clean up. That's 4x. For this piece I use negative times positive theorem. For that piece I use negative times negative theorem. And that's beautiful. Here, I'm going to show you how by inspection works. You combine these two, you associative law of addition, because you're adding 3 items. This plus that, you can just add these two. So that gives you negative 5 plus 4x, and I'll use by inspection because those are steps just like the ones I did earlier. And that's as good as it gets for now, which is a degree 0 term. This is a degree 1 term. We really can't add them per se, at least not at this moment. Alright, nice, step by step. Beautiful stuff. Should we try this one? Oh wait a minute. I think this one looks more fun. Or that one. Yeah, let's try this one. This one has everything. Ooh, I love it. So this will become... Let me take a little break here. Alright, so let's do this slowly and carefully. So first thing I do is I don't like these subtractions, so I go with 2 plus negative 2 to the third plus negative 3 times negative 3 plus, whoa, negative 2 plus negative 5 plus 2. So I changed this one, I changed it to plus and I moved the minus over. This one I changed it to plus and I moved the minus over. This one I changed it to plus and I moved the minus over. And this one's already a plus, so I like that, negative 4 squared. All I did here is definition of subtraction. And then I make a little note of it. How many terms do I have? These are my terms. I got 1, 2, 3, 4 terms so far. 4 terms. I only do little pieces that I know I can handle. So I know this means 2. I know that this means negative. I know that here the base is 2 and the exponent is 3. So this is 2 times 2 times 2. That's 3 times. And I know this is 1 term and this is another term. Plus. Alright, here I know what that means. That means write whatever's there twice. The 3 I can't really distribute because of that exponent. You shouldn't be distributing and just ignore whatever's to the right. We never do that. You can't distribute and ignore whatever's to the right because there might be something there that means something else. So I do like negative 3 times negative 2 plus negative 5. I know that means for sure that squared, and then I know this means negative 4 times 4. And of course I just use natural exponents here, natural exponents. Natural exponents here, natural exponents there, natural exponents there. And now I see I have, again, I look for my bookmarks here, my partitions, my separators, the plus, the plus, the plus. That separates it into 4 terms. I just have to handle each one separately. It's its own little problem. This will give you 2 times 2 is 4 times 2 is negative 8. See, there we go. I'm using by inspection. Here I'll handle that separately in a little bit. Negative 4 times 4, negative 16. That's negative times positive theorem, which could also be covered by inspection. Here, what's going on here? I have 3 items that are being multiplied. Multiplied, multiplied. This is being multiplied, and that's being multiplied. So the operation here is multiplication. That item times that item times that item. Wait, maybe I can clean it up a little bit. Negative 3 times negative 7 times negative 7. Yeah, that's by negative plus negative theorem. So still I have, I'll make a note of my terms here. My terms are separated with pluses. This piece right here, it's 3 items being multiplied. Whenever you have 3 items being multiplied, either you can group these two or those two. That's called associative law of multiplication. So I'll work on, maybe I can multiply these two. So this would be called associative law of multiplication, where I just focus on those two, and that gives me 21. 21 times negative 7 plus negative 16. And there I use associative law of multiplication and negative times negative theorem. First I associated, that's how I was able to focus on those two. Imagine that I put big parentheses there. And so, because I have 3 items there, I can just put parentheses on these ones and focus on those. And that's how I got 21. And then I can maybe take it one step further. I have here 2 plus negative 8 plus, how much is this? Well, 7 times 20, that'd be 21 times 7. That's 7, 140. I'm thinking that's negative 147 plus negative 16. And that's by negative times positive theorem. Okay. Now what can we do? We could combine these two. Let me think. We could combine these two, because now I have 4 items being added. 1, 2, 3, 4 items being added. When you have 4 items being added, you can either group these two or those two or those two. The associative law of addition says you can add this pair first, or that pair, or that pair. It doesn't matter. I can add these ones or those or these. It's all good. In fact, I'll just add these two. That gives me negative 6. And I'll just add these ones. That gives me negative, so I have to do that plus 16. So that would be 3. And I have 1. That would be 6. And I have 1. So that gives me negative 163. And that's just by inspection. I used a bunch of things. On this one I used negative plus negative theorem. And also associated these. And on these ones I used a bunch of ideas. That gets me to 6 plus 160, negative 6, that's that one, and negative 163. I'll continue up here. That gives me equal to negative 169 by negative plus negative theorem. And that's beautiful right there, step by step by step by step by step. Okay? Always being mindful of how many terms I have and working with each term separately. You have no good reason for chopping up terms. The only thing that's allowed to do that usually is a distributive law, but if we're not sure whether or not you should chop up terms, then don't chop up the terms. Alright, that was fun. Hopefully you guys get a chance to practice this. We'll see you guys next time. Peace.